A very good morning. We've been now seeing the verification of law of chemical combination. In here, we have a solution of chemical chloride in the conical flask, whereas we have sodium sulfate solution in the test tube. When we mix it together, what we get is the white precipitate of CaSO4 in a NaCl solution. Here we have CaCl2 in the conical flask, whereas we have NaSO4 in the test tube. So what happens is when we mix it together, we get CaSO4, that is Cl2 and Na2 gets eliminated by that. So what they say is Antoine Lavoisier inferred from his research that there is no rise or drop in the weight of the matter during chemical reaction. So this is the law of conservation of matter. In a chemical reaction, the total weight of the reactants is same as the total weight of the products formed due to the chemical reactions, and this is called the law of conservation of matter. Gilles Proust stated the law of constant proportion. As we said before, the weight of the constituent elements in the various samples of a compound is fixed. Example, the proportion of weight of hydrogen and oxygen in water is 1 to 8. This means that in 9 gram of water, 9 gram of water is formed by chemical combination of 1 gram hydrogen and 8 gram oxygen. Similarly, in carbon dioxide, 3 is to 8 ratio of carbon and oxygen is present. That is, in 44 gram of carbon dioxide, there is 12 gram of carbon and 32 gram oxygen, so that the proportion by weight of oxygen and carbon is 3 to 8. What atom is and what is the size, mass and valency of an atom? We have learned in the previous standard that the center of an atom is the nucleus, that there are moving electrons in the extranuclear part, like this. In an atom, at the outermost shell, electrons are present, whereas in between, nucleus is present, which comprises of positively charged particles, whereas the electrons are negatively charged elementary particles. Look at the image of an atom obtained with the field ion microscope. In chemistry, the size of an atom is determined by its radius. The atomic radius of an isolated atom is the distance between the nucleus of an atom and its outermost orbit. Atomic radius is expressed in nanometers, that is 10 to minus 9. In 10 to minus atomic radius of particular examples are given here. Hydrogen atom is of 10 to minus 10 nanometers, that is Nm. Nanometers is Nm. Water molecule is of 10 to minus 9, whereas hemoglobin molecule is 10 to minus 8. I just hope that you all know what hemoglobin is. It is present in our blood, which supplies oxygen. What is the mass of an atom? The mass of an atom is concentrated in its nucleus, and it is due to the protons and neutrons present in it. The number P plus n, that is proton plus neutron, in the atomic nucleus is called the atomic mass number, whereas protons and neutrons are together called nucleons. What are protons? Protons are the particles containing positively charged, whereas neutrons containing negatively plus positively charged atoms that neutralize each other. What atomic mass is, you have to remember all these definitions. The number proton plus neutron in the atomic nucleus is called atomic mass number. An atom is very, very tiny. Then how do we determine its mass? Scientists too struggle with this question. It was not possible for scientists of the 19th century to measure atomic mass accurately. Therefore, the concept of relative mass of an atom was put forth. The reference was chosen as the hydrogen atom being lightest in weight. The relative mass of an hydrogen atom, which has only one proton in its nucleus, was accepted as 1. Therefore, the magnitude of the relative atomic masses of various atoms became equal to their atomic mass number P plus N. The mass of one nitrogen atom is 14 times that of a hydrogen atom. Therefore, the relative mass of a nitrogen atom is 14. Therefore, in this course of time, different atoms was chosen as reference atoms. Finally, in 1961, the carbon atom was selected as a reference atom. In this scale, the relative mass of a carbon atom was accepted as 12. When elements and compounds take part in chemical reactions, it is the atoms and molecules that react with each other, and therefore it is necessary to know the numbers of their atoms and molecules. However, while carrying out a chemical reaction, it is convenient to measure out quantities that can be handled instead of counting the numbers of atoms and molecules. A mole is that quantity of a substance whose mass is grams and equal in magnitude to the molecular mass of that substance in Daltons. Thus, the molecular mass of oxygen is 32 units, and therefore 32 grams oxygen is 1 mole of oxygen. You have to see to it that you are remembering each and every definition. The molecular mass of water is 18 units, therefore 18 grams of water make 1 mole of water. Number of moles of substance N, small n, is equals to mass of substance in grams upon molecular mass of a substance. What is Avogadro's number? The value of Avogadro's number is 6.022 into 10 raised to 23. A mole of any substance stands for this molecule, just as dozen or has 12 items, a century has 100, a gross has 144. A mole means 6.022 into 10 raised to 23. The number of moles in given height CO2 small n is equals to mass of CO2 in grams divided by molecular mass of CO2, that is 66 divided by 44. N is equals to 1.5 moles. So what we have to do, we have to just divide this by the Avogadro's number, that is 6.022 into 10 raised to 23 molecules, which is 9.033 into 10 raised to 23 molecules. Let's stop it here. We'll be starting with the next topic in the next video lecture. Thank you.